This lesson is based on the textbook Modern Welding, 11th edition. If an alternate edition is used of Modern Welding, you will have to look up the chapter that pertains to the material covered. Chapter 12, Oxyfuel Gas Welding. Objectives. Define welding as a joining process. Demonstrate the safe storage, handling, and movement of oxygen, acetylene, and other fuel gas cylinders. Accurately and safely assemble an oxyacetylene welding outfit. Demonstrate the correct method for testing for leaks on all components of the oxyacetylene welding outfit. Demonstrate the correct method of starting and shutting down an oxyacetylene welding outfit. Objectives. Select the correct tip size, working pressures, and welding procedure to use for welding various thicknesses of mild steel in various positions. Adjust a neutral flame and other types of welding flames. Distinguish between good and defective welds. Pass a test on the safe practices and procedures to follow for oxyfuel gas welding. Objectives. Make a quality weld on a butt, lap, corner, and T-joint showing complete penetration. Produce welds in the flat, vertical, horizontal, and overhead positions. Run a continuous weld pool on base metal using an oxyacetylene welding torch. Oxyfuel gas welding. Oxyfuel gas welding is widely used for repair work, fabricating small projects, and cutting. The fundamentals include basic skills important to other forms of welding. The process is a popular manual process. It is easy for beginners to observe the fusion process during oxyfuel gas welding. Introduction to oxyfuel gas welding. Oxyfuel gas welding is a metalworking process. It joins pieces of metal by heating them with a gas flame to the melting point. It allows molten portions to fuse together. Continuous practice is necessary to develop and maintain a high standard of skill as a welder. Brazing and soldering. Brazing is done when two metals, which are not melted, are joined with a third metal that melts at temperatures above 840 degrees Fahrenheit. Soldering occurs when two metals, which are not melted, are joined by a third metal that has a melting point below 840 degrees Fahrenheit. Oxyfuel gas welding process. Using an oxyfuel gas flame as a heat source is a popular welding method. This method provides a clean flame with an extremely high temperature that produces the heat needed for welding. Welding flames. In oxyfuel gas welding, a very intense, concentrated flame is applied to the metal. The molten pools run together and fuse. The edges of the two pieces become one. To obtain more heat, a torch tip with a larger orifice is used to produce a larger flame. The thickness of the metal that can be welded depends on the quantity of fuel gas burned per unit of time. Welding flames. There are several commonly used oxyfuel gas welding and cutting flames. Oxyacetylene, used for welding and cutting. Oxyhydrogen, used for welding and cutting. Oxynatural gas, used for cutting and heating. And oxypropane, used for cutting and heating. Welding flames. Harmful flames are created when the wrong proportions of oxygen and fuel gas are used. If there is too much oxygen, an oxidizing flame burns the metal. If there is too much fuel gas, a carburizing flame results. Welding flames. An oxyacetylene welding flame is the hottest oxyfuel gas flame. It is hot enough to melt common metals. Oxyfuel gas welding outfit. The oxyfuel gas welding outfit consists of the oxygen and fuel gas source, the regulators, hoses, and hose fittings for each gas, and a welding torch. There are two types of gas welding torches: a positive pressure torch and an Injector-Type torch. Oxyfuel gas welding station. The welding station includes the welding outfit, plus a welding table, holding fixtures, ventilation, and possibly a booth. This illustration shows a portable welding and cutting station. Assembling the welding outfit. Oxygen cylinders and most fuel gas cylinders are usually owned by the companies that supply the gases. The rest of the welding equipment is usually owned by the welder or employer. Great care must be used when handling cylinders. Before welding, make sure the equipment is properly assembled. Before attaching a regulator to a cylinder, the cylinder opening should be cleaned out by cracking. Be sure the regulator nut fits the cylinder valve fitting properly. Safety. Be certain that there is no exposed flame in the area and that the cylinder opening is pointed away from any person or possible flame source when a fuel gas cylinder is blown clean. Fuel gas and oxygen cylinder valves have different threads. Fuel cylinders are usually fitted with left-hand threads. Oxygen cylinder valves are fitted with right-hand threads. The thread diameters are usually different as well. Assembling the welding outfit. A flashback arrestor should be installed between the regulator and the hose. A check valve should be installed between the hose and the torch body. To test for leaks, put a soap and water solution on the outside of the joints and observe for bubbles. Safety. A flame or oil of any kind should never be used to test for leaks. Do not use the system until the leaking joints are repaired. After the parts have been replaced or repaired, perform another leak test before lighting the torch. Handling cylinders safely. A cylinder truck should be used to move a cylinder. The cylinder must be properly secured so that it cannot tip or fall off the truck. Avoid storing or using cylinders in extremely hot places. Safety. Cylinders should never be dropped or tipped over. The cylinder safety cap, which encloses and protects the cylinder, should always be in place when the cylinder is not in use or is being moved. Selecting a torch tip. The tip size of a welding torch is determined by the size of the orifice. The orifice size determines the amount of fuel gas and oxygen fed to the flame. If the torch tip orifice is too small, not enough heat is available to melt the metal. If the torch tip is too large, poor welds result. Turning on the oxyacetylene outfit. Visually check the condition of the equipment. Inspect the regulators. Turn the regulator adjusting screw all the way out or until no tension is felt before opening the cylinder valves. Slowly open the acetylene valve 1/4 to 1/2 turn using the proper size wrench or valve handle. Open the oxygen cylinder valve very slowly all the way open. Safety. Stand to one side of the regulator when opening the cylinder valves. A burst regulator or gauge could cause severe injury. Leave the wrench on the valve in case an emergency shutoff is needed. Turning on the oxyacetylene outfit. Open the acetylene torch valve 1 turn. Turn the regulator adjusting screw in slowly until the correct pressure is indicated. Open the torch oxygen valve 1 turn. Turn the regulator adjusting screw in until the correct pressure is indicated. Safety. Never use acetylene gas at a gauge pressure above 15 psi. Check the low pressure gauges after a few seconds to see if the reading has increased from the working pressure that was set. If so, close the oxygen and acetylene cylinder valves immediately. An increase in pressure indicates that the pressure regulator valve is leaking. Lighting a positive pressure torch. Open the acetylene torch valve no more than 1/16 turn and use a spark lighter to ignite the gas. Continue to open the torch valve until the acetylene flame jumps away from the tip. Another method for determining the correct amount of acetylene is to increase the flow until the flame becomes turbulent. Lighting a positive pressure torch. After the acetylene is regulated, slowly open the oxygen valve on the torch. If the torch burns with an irregular contour to the cone, the flame is called a carburizing flame. Regulator gauge readings. After adjusting the pressure on the regulator low pressure gauge, the torch valve is closed. There is a slight rise in pressure on the low pressure gauge, which is normal. The flowing pressure is always lower than the pressure when the torch valve is closed. Safety. The low pressure gauge reading could continue to rise after the torch valve is turned off. This indicates a leaking regulator nozzle and seat. Turn off the cylinder valve immediately. Replace or repair the regulator before using the station again. Turning on an outfit and lighting an injector-type torch. Inspect the equipment to make sure all parts are in good operating condition. Inspect the regulators. The adjusting screws should be turned all the way out before opening the cylinder valves. Open the oxygen cylinder valve very slowly until the high pressure gauge reaches its maximum reading. Turn the valve all the way open, as oxygen valves are back seating valves. Safety. Never stand in front of the regulator when opening the cylinder valves. Injury may result if the regulator or gauges rupture. Good practice is to put the cylinder between you and the regulator when opening the valve. Turning on an outfit and lighting an injector-type torch. Slowly open the acetylene cylinder valve 1/4 to 1/2 turn. To adjust the oxygen torch pressure, open the torch oxygen valve fully. Turn the adjusting screw on the oxygen regulator until the low pressure gauge shows the appropriate pressure. Turning on an outfit and lighting an injector-type torch. Purge the system. Open the torch oxygen valve 1/2 turn. Open the torch acetylene valve 1/4 turn. Light the gases at the tip with a spark lighter. Adjust the valves to reach the desired flame. Torch adjustments. A torch can be adjusted to produce the following flame characteristics: a neutral flame, a carburizing flame, or an oxidizing flame. A disruption of gas flow at the tip causes a backfire. If the backfire is not stopped, a flashback can result. Safety. Flashback is an extremely dangerous occurrence. Action must be taken immediately to extinguish the flame. Shut down the acetylene and the oxygen as quickly as possible. Have the equipment inspected by the proper personnel. Turning off a torch. If leaving the station for a few minutes, simply turn off the torch. First, turn off the acetylene, fuel gas. Next, turn off the oxygen torch valve. If the equipment will be idle for more than a few minutes, the outfit should be completely shut down. Shutting down the outfit. Close the acetylene torch valve. Then close the oxygen torch valve. Open the hand valves on the torch until both gauges read 0, bleeding the system. Turn the adjusting screws on the regulators all the way out or until no tension is felt. Lightly close both hand valves on the torch. Torch positions, movements, and angles. Moving the torch in the direction that the tip is pointing is called forehand welding. The travel angle is the angle between the axis of the torch and a line perpendicular to the weld axis. The travel angle for forehand welding can also be called the push angle. Torch positions, movements, and angles. The work angle is the angle between a line perpendicular to the major workpiece and a plane determined by the center line of the torch and the weld. In the illustration, this is a 90-degree work angle. Torch positions, movements, and angles. In backhand welding, the torch tip points back toward the weld bead that was created. The travel angle for backhand welding is also called the drag angle. The tip of the welding torch should be moved slightly as the weld progresses. A weaving, oscillating, or circular motion is usually used for backhand welding. Running a continuous weld pool. A beginning welder should practice running a continuous weld pool. The size of the weld pool is in proportion to its depth. The appearance of the surface of the pool indicates the type of flame being used. A correctly adjusted flame prevents oxidizing of the surface of the pool. Running a continuous weld pool. If the weld pool sinks or sags too far, lower the angle of the torch or increase the speed of movement. The eye of the weld indicates the movement of the molten metal. Welds made without welding rods. A square groove outside corner joint can be welded without the use of a welding rod. An edge joint also can be welded without welding rod. Both types of joints make good welding exercises for beginners. Welds made with a welding rod. To become proficient in gas welding, certain exercises must be planned and practiced. The basic joints are butt, corner, edge, lap, and T. Welds made with a welding rod. The basic welding positions: flat, horizontal, vertical, and overhead. Welding rod in running a bead. To obtain a strong weld, metal from a welding rod is fed into the weld pool. This decreases its depth and increases the thickness of the metal in the weld area. The bead in a correctly made groove weld should be slightly convex. Welding rod in running a bead. Fillet welds can be made with either a convex or a concave bead. Groove welds must be flush or convex. A concave groove weld would be underfilled, and that is a defect. Welding rod in running a bead. As the welding rod melts, it becomes necessary to reposition your grip on the welding rod. Some welders have a natural ability to reposition their grip, while others need some practice. A good weld can only be achieved by coordinated handling of the welding torch and the welding rod. Safety. Do not place the rod against your body to slide your hand to a new position. Many welders have been injured when the tip of the welding rod burned through their clothing and touched the body. Joint preparation for plate welding. Several edge preparations have been developed to make the edges of thick metal ready for welding. Square, bevel, and V-groove joint preparations are the most common. Welding butt joints. A butt joint weld is one of the most common welds made with the Oxyfuel gas torch. The pieces should be clean and flat. The edges should be straight. After the metal is prepared, light the torch and adjust it to a neutral flame. Welding butt joints. Bring the torch to the point where the weld is to start. The torch flame melts a pool on the edge of each piece. The weld pool should spread equally over the two pieces. Apply the welding rod to the leading edge of the weld pool until the desired crown is built. Welding butt joints. The torch tip should be kept at a consistent distance from the weld. The travel angle should remain unchanged. The keyhole procedure is often used on thicker metals that have been beveled. Welding lap joints. The joint consists of lapping one piece of metal over the one which is to be welded. Before adding the filler metal, a C-shaped weld pool must be visible. Welding lap joints. Concentrate the torch flame on the lower surface. The welded portion must be as thick as the original metal. To provide this thickness, add enough welding rod metal to make a convex bead. Welding lap joints. A plug weld on a lap joint is a circular weld made through a hole in one member of a lap joint, fusing that member to the other. A slot weld is like a plug weld, except an elongated hole or slot is cut instead of a round hole. Welding outside corner joints. Outside corner joints can be made without using welding rod. If a convex bead is desired, sufficient filler metal will be required. Welding inside corner and T-joints. The preferred method is to have the two pieces set at a 45-degree angle. This is the flat welding position. The two pieces should be tacked at points along the joint before welding. Welding inside corner and T-joints. A second method is to have one piece horizontal and the other vertical. The weld is in the horizontal welding position. When welding this joint, the torch flame is placed close into the corner. To produce fusion at the root of the weld, hold the torch as close as possible without allowing the inner cone of the flame to touch the metal. Welding inside corner and T-joints. Neither piece of base metal should show any signs of being undercut. When making a T-joint in a horizontal position, use a forward inclined half-moon torch motion. Safety. Testing a weld for penetration may be done by striking the weldment with a hammer while holding it in a vise. A metal screen or heavy material barrier should be installed around the vise whenever an attempt is made to break a weld. The screen prevents the broken pieces from flying into the shop area. Using a locking jaw pliers is a good way to fold a weld onto itself. Welding positions. The recognized welding positions are flat, horizontal, vertical, and overhead. Obtaining a good bead is more difficult in horizontal, vertical, and overhead positions. Welding in horizontal position. This position consists of welding a horizontal joint on a vertical surface. The torch tip should point at a slightly upward angle instead of directly along the weld joint. Welding in vertical position. Vertical welding consists of welding in a vertical position on a vertical surface. The weld should proceed upward. The torch tip is pointed upward. Some slight torch motion should be used so that the gas stream keeps the molten metal continually in position and prevents sagging. Welding in overhead position. Overhead welding is the most challenging welding position. The force of the gas velocity in the torch flame, plus the surface tension of the metal in the pool, helps overcome the pull of gravity on the molten metal. A whipping motion can be used to help keep the molten pool from becoming too hot. Safety. The welder's body, head, and hands should be protected with fire-resistant work clothes, a cap, and gauntlet-type gloves. The welder should wear high-top leather shoes. Pockets should be covered and collars buttoned. Pants should not have cuffs, frays, or tears. Backhand welding. Backhand welding requires the torch to be held at a drag angle of 30 to 45 degrees. The flame should point back at the part that has been welded. Use a whipping motion to move the flame away from the weld at frequent intervals so the edge of the pool can solidify into a bead. Multiple pass welding. Multiple pass welding is welding a number of thin passes on top of one another. It is used primarily to make welds in thick metal. Welding the joint with several passes can help avoid trapping contaminants in the weld. The layers can be made continuously or by using the step method. Appearance of a good weld. The weld should be of consistent width throughout its length and should be straight. The weld should be slightly crowned or convex. The weld should be fused into the base metal with a blended appearance. The weld should have a clean appearance. The weld should have consistent and efficient penetration and fusion. Appearance of a good weld. In lap joints and T-joints, the most common problem is a lack of fusion along the toe of the bead. Undercutting can also be a problem with welds. Safety. Welders should know the precautions and follow them for their own safety, for the safety of others, and to protect the equipment. Protecting clothing and equipment. When welding, wear the following: goggles or a helmet with a proper filter lens, leather welding gloves, a cap and leather jacket or cape for overhead welding. Remove combustibles from pockets. Never weld with butane lighters in your pocket. Also, use fireproof materials as supports. Welding or cutting tanks and containers. Do not weld or cut a tank or container unless it has been processed to be safe. Many substances that are not usually flammable or explosive become vaporized and explosive when heated to a high temperature. Handling oxygen and fuel gas cylinders. Keep all oxygen equipment free of oil and grease. Secure gas cylinders so they cannot tip over. Keep cylinder caps screwed on all cylinders that are not in use. Keep empty cylinders separated from full cylinders. Oxygen and compressed air are not the same thing. Handling oxygen and fuel gas cylinders. Store full and empty cylinders separately. Around electrical equipment, insulate the cylinders with wood or rubber. Do not expose cylinders to high temperatures. Tag cylinders with leaks and move them to a safe area. Notify the supplier to pick up leaky cylinders. Handling the Oxyfuel gas welding station. Purge the cylinder valves before attaching the regulators. Use a well-fitting wrench to attach regulators and hoses. Do not use a pliers. Purge the hose before attaching to a torch. Do not interchange fittings on hoses. Install flashback arresters and check valves. Keep hoses away from oil and grease. Examine hoses carefully. Handling the Oxyfuel gas welding station. The adjusting screw on the regulator must be turned out before opening the cylinder valve. Open the cylinder valves slowly. Stand to one side when opening cylinder valves. Check for leaks using a non-petroleum-based soap and water solution. Purge oxygen and fuel gas valves, regulators, lines, and torch passages before use. Safety. When purging fuel gas valves, regulators, and hoses, be sure no open flames are near. Fuel gases are flammable. Never use a settling pressure in excess of 15 psi. Welding regulator safety. Clean the cylinder passages prior to fitting a regulator to a replacement cylinder. Examine the condition of the threads on the regulator and cylinder fittings. Use the proper wrench to tighten the regulator fitting to the cylinder. Teflon tape or paste made of glycerin and litharge should be used to seal the threads that connect the gauge to the regulator. Never interchange oxygen and fuel gas regulators or gauges. Welding regulator safety. Turn the regulator adjustment screw all the way out or until no tension is felt before opening the cylinder valve. Safety approved regulators incorporate a safety disc on the low pressure side. Watch the gauges to ensure that the pressure does not continue to go up or there is a leak. The pressure to be used in a gauge should never be greater than 2/3 of the maximum calibration of the dial. Safety. Aim the cylinder valve opening away from workers and open flames during a cleaning operation. Fuel gas cylinders usually have left-hand threads. Oxygen cylinders have right-hand threads. Regulators, hoses, and torches have matching threads for fuel gas and oxygen. Never use common pliers or pipe wrenches to tighten regulator fittings. Open the cylinder valve slowly. Do not stand in front of a regulator as the cylinder valve is opened, even when opening it very slowly. Handling torches safely. Do not put a cold tip in a hot tip tube. Torch hand valves should be turned only with the fingertips. Be sure no combustible material is in the area when a torch is lighted. Use a spark lighter to light a torch. Backfires are often caused by a dirty tip, overheated tip, or insufficient working pressures. Be careful when cleaning a tip with a tip cleaner. Safety. Be sure no flammable material is near the welding station. Be careful that the torch is not directed toward a person while it is being lighted. If a torch backfires, find the trouble and remedy it before continuing to use the torch. In case of a flashback, immediately extinguish the flame and close the cylinders and regulators. Never leave a lit torch unattended. Metal fume hazards. Many metals release irritating and toxic fumes when heated. Metals that release the most dangerous fumes are cadmium, zinc, lead, and beryllium. Dangerous fumes can be removed using fume extractors. Metal fume hazards. Cadmium is widely used as a rust protective coating over steel. Zinc is widely used in die-cast metal parts. Lead is used for some tanks and pipes. Some paints may contain lead oxide pigments. Beryllium is used in aerospace applications where rigid, lightweight metals are needed. Safety. The fumes generated by welding, brazing, or cutting cadmium-coated metals are very dangerous. Very thorough ventilation must be provided during these operations. When heated, zinc gives off a vapor that is very irritating to the respiratory system. Very thorough ventilation must be provided when welding zinc. Safety. When heating any substance containing lead, thorough ventilation is required. Lead poisoning may occur without any warning since its fumes are not irritating. A person exposed to lead may develop acute lead poisoning. Excellent ventilation must be provided when beryllium is welded since its vapors are toxic. Assembling the welding outfit. A flashback arrestor should be installed between the regulator and the hose. A check valve should be installed between the hose and the torch body. To test for leaks, put a soap and water solution on the outside of the joints and observe for bubbles.